the radical value, you can reduce this radical to the square root of 4 by the square root of 11. In which case you get the square root of 4 reduces to 2. And you get 2 square roots of 11, which is equal to 6.63, which is the height. We calculate for the area, so we know that the area of any triangle is equal to 1/2 base times the height. Or I like to use it in this form, in this rational form, base times height over 2. Okay, so the base is BC and the height is H, or AD. Okay. So we say BC, okay, by the height AD. Over 2. And the reason we don't use a H, we don't use a H because it wouldn't be, the way that you're writing it would not be consistent. It's not consistent notation. To say BC is to say our notation, we're using conventional notation, which means to say that we're determining the line by its points, by their endpoints. Okay, so you should do it either one way or the other. Here, that's why instead of H, I put its equivalent AD, where H equals line segment AD, the height. Now here, for the area, we get the length of BC, which is 20, by the height, which is 6.63, over 2. So calculating this value, the 132.6 over 2, or 66.3 square units, or you would say units squared. You could say square units. So here, now we're going to discuss an equilateral. Take a note on an equilateral. When the height is drawn to any side in an equilateral triangle, it bisects that side. So an equilateral triangle, all sides are equal. So if you draw a height to either side here is going to bisect it. Okay, cut it, which means to cut it in half. Okay, now if this was perfect, this would be, all these would meet right in one point. Okay. Okay, so here Now anytime, now a point can be at the end of a line, or it could be on a part of a line. A point is also the intersection between two lines. Okay, so when we draw a height here in this equilateral triangle from C to side AB, we make the point D. Alright? So the lengths, so here this is equivalent to D on this one. Okay, now this would be A, B, C. Alright, so AB is equal to AC, which is equal to BC. Now we want to find DC. Now here, if the sides are known, if the sides are known, we can find the length of the height, which is DC. Now, of course, we're going to use here, this forms the right triangle. We're going to employ the use of the Pythagorean, of the triangle theorem attributed to Pythagoras. Okay. Okay, so now here, CD or DC, this is the height. Okay. So, also, now one interesting, which is going to be the first way, we're going to use this method first, is to see how, if by assigning a unit value of 1 to each side, okay, we say each side is equal to 1. Okay, so here, this would be 1. Okay, if AC is 1, then AD is 1/2. Okay, now we want to see what is CD or DC. Okay, now here, okay, we use the Pythagorean theorem. You know, most people are familiar, and by the way, you can only use, the Pythagorean theorem doesn't work for triangles other than right triangles. They don't work for oblique triangles. Okay, so most people are used to seeing the Pythagorean theorem, okay, in this form with letters, which is the way it's used, generally taught. But here we're not using that notation, we're using endpoint notation. Okay. So substituting that we say AC, the square of AC is equal to uh, the sums of the squares of its legs. All right, so our